Hello those students and welcome to your Physics 10 class. Today we'll be looking at the topic measurements. Under measurements we'll be looking at time. So what is time? Time is what a clock reads. If you've been following us, time is a scalar quantity and it's measured in seconds. What are the instruments used to measure time? The stopwatch, the clock, and the pendulum. In this lesson, we'll be mainly focusing on the pendulum. So, a pendulum is simply a bulb that has been suspended on a string. Under the pendulum, there are some terms you need to be conversant with, which are the period. The period is simply the time taken for one complete oscillation of a pendulum. The SI units are seconds. If you are asking yourself what one complete oscillation is, it's simply A to B and back to C. So it's simply the motion of the pendulum from start and back to start. The other term we should be conversant with is frequency. Frequency of a pendulum is the number of complete oscillations made by a pendulum per second. Its SI units are Hertz. Now let's look at the formulas used in the pendulum, or the formulas used when dealing with the pendulum. So the first formula is period, which is equal to time over number of oscillations. In symbols, it's simply written as capital letter T is equal to small letter t over n. You should remember this formula whenever you're dealing with the pendulum. The other formula is the frequency. Frequency is equal to 1 over period. In symbols, it's written as f over 1 over t. But sometimes you would like to replace the period with t over n, and hence f will be equal to 1 over t over n. And hence this will be simply multiplying f. It will be simply multiplying 1 over 1 by the inverse of t over n, which is n over t, and hence our frequency will be equal to n over t. So frequency will give the same values if you use f is equal to 1 over t or f is equal to n over t. There's no difference in the two formulas. They still give the same answer. Now let's look at some questions dealing with the pendulum. Question 1. It takes 2 seconds for a pendulum to swing from A to C. Find its period and frequency. So our first step is collecting our data. In physics, data is very important. So we get our time, which is plainly stated 2 seconds. Then we find the number of oscillations. It should be noted that the number of oscillations is just given in a phrase form. Hence, we'll need to figure out how much or how many oscillations were made. So the movement from A to C is basically half an oscillation, because this point A is the extreme point on our left side and C is the extreme point on our right side. Hence, a full oscillation is A to C and back to A. But the pendulum only moved from A to C. Hence, it only covered half the distance it was supposed to cover. And hence, our number of oscillation will be 0.5. Now let's look at how we can find the period. To find the period, we simply first state our formula, which is t is equal to t over n, and then plug in our values. 2 divided by 0.5, and our period will be 4 seconds. Next, we find the second part of our question, which is the frequency. We first get our data. T is equal to 4 seconds. we just get the same period we found as it applies to the same question. Then we write our formula, plug in our values, and simplify, which gives us frequency equal to 0.25 Hz. Example 2. It takes 4 seconds for a pendulum to swing from A to C and back to B. Find its period and frequency. So first we get our data, which is t is equal to 4 seconds. Then we find our number of oscillations. Should be noted, in the previous example we just used the swing from A to C, which was half, but this time our pendulum came back to B. So what I would like you to understand in this example is that a pendulum makes 4 quarter swings. The movement of A to B is a quarter swing, and B to C is another quarter swing. Hence, a quarter plus a quarter gives us half, and that's true. AC is half a swing. So what happens when the pendulum swings back to B? When it swings back to B, it makes another quarter movement. Hence, we have 3 quarters, or simply 3/4 oscillations. When this is taken into decimal form, we'll have 0.75, and this is the number of oscillations. Now we solve our period. And hence, our period is equal to 5.33 seconds. If this is punched into a calculator, you see that the number of 3's is limitless. There are a lot of number of 3's after the decimal point. If we round it off, it will still give us 3, as 3 is a number less than 5. Now let's find the frequency. Frequency is equal to 1/t, and our period is 1.33. Hence, our frequency will be 0.19 Hz. Example 3. A pendulum has the period of 8 seconds for 2 complete oscillations. Find the time of the pendulum. So first we collect our data. We've been given our period, which is 8 seconds, and our number of oscillations that are complete, which is 2. Then we write our formula and see what we don't have. So we've got our period and our number of oscillations, but we do not have t. So to make t the subject, we make t the subject of the formula, and hence time taken will be equal to period times number of oscillations. Then we plug in our values, and t will be equal to 8/2, and hence the time taken will be equal to 16 seconds. Hence we have solved this question too. Note, in this question we haven't used any of the diagrams, as we had been given the number of oscillations already. So thanks for watching today's video, and remember that in this lesson we've covered the measurement of time, how time is measured, and its SI units, the terms associated with the pendulum, formulas associated with the pendulum, and questions associated with the pendulum.